Hello, welcome everyone. Whoever's going to be watching this, which I doubt anyone will. But anyways, my name is Devin Adams. I am a Fortinet instructor for DWWTC here in Tempe, Arizona. And here in this demo, I am going to demonstrate how to get redundant VPN connections. Now, I do these videos as an extension to the classes that I teach. So I just share them here on YouTube because I know there's not that much resources out there. Anyways, this demo goes out to my friend Randy, who was wondering, all right, well, in class, we had a dual VPN connection solution. So in class, we had WAN 1, WAN 2, then on the remote side, we had WAN 1, WAN 2, and then we had a primary tunnel and then a secondary tunnel. Well, the only problem within the lab is if one of these connections go down, it brings down WAN 1. So if WAN 1 disappeared over here, it'd bring down WAN 1 over here. So Randy's question was, well, isn't there a way that we can get full redundancy? In other words, if WAN 1 stays up all the time, there shouldn't be a reason to force the other WAN connections to go down too, right? And that's what we're going to try to do here. We're going to try to do a full redundancy instead of just a primary and a backup. So we'll have essentially 4 tunnels on each side. So here's LA, here's New York, and let me zoom in a little bit so we can see what's going on here. And our goal here is to have this network right here connect to this private network over here across our pseudo WAN interface over here. And regardless of which switch I disconnect, right, we should still get full redundancy. All right, so now I did copy a couple of shortcuts to the actual cookbooks that demo this from Fortinet itself, and they have you go through the custom tunnels to do this. Well, I'm lazy, guys. I'm not going to lie. And also, I apologize that this looks so bad, too. I'm not really a graphics designer or a YouTuber. Anyways, but I'm lazier than that. So I was wondering, you know what? Can we just use the VPN wizards? Now, I'm not quite sure if this is going to work exactly, but I also like to record my failures. Okay. And the reason why is because I think they do a good job also helping us learn about what not to do. And sometimes that's just important as what to do. So anyways, let's go ahead and first start with our PC over here in Los Angeles. So here we are, and I'm going to load up the management interface to my local FortiGate here. All right, and that's going to be 10.0.1.254. There we are. And let me log in real quick, and let's see what's going on here. Now, on purpose, because I was doing it for other demos, and also just to make things a little bit more interesting, I am using a WAN link load balancer on my network. So if I go over here to WAN link load balancing, you'll see that port 1 and port 2 are clustered together. All right, so and then we have it distributing traffic accordingly. So I'm going to show in this demo how that doesn't matter. We can still push down VPNs individually, and normally we can't do that, but using the wizards and everything we can. So because once you actually make that one logical interface, as you can, let's go ahead and just take a look here real quickly in our IP4 policies, you'll see it's only being referred to as one port. Oh, that's my DMZ. There we go. So we pretty much have a LAN 3 or a port 3 as our LAN or our trust, and then the WAN link load balance gets subtracted because of the link load balancing. Now, if you're in 5.6, that's what they're now calling the software-defined network, so or the software-defined WAN. So not to get those confused, but I'm going to show that that doesn't really matter. All right. Also, if I go ahead and load up another tab, and I go to my remote FortiGate, and everything in these demos, by the way, I try to simulate the classroom lab environment as much as possible. If it has a 10.200, we're going to make believe that those are public IP addresses. So because we actually utilize the web, we can't use real public IP addresses. But here we go. This is the remote FortiGate, and there's a couple of things special on this one. For starters, if you notice the GUI change, this is 5.6. Now, I need to start getting used to 5.6, so I've been forcing myself to use it more. A lot more features, a lot prettier interface, a lot of neat little details here and there that's making the GUI experience just absolutely wonderful. So as an example here, if I go to my network, you see how we have SD-WAN here, right? Now, I did not abstract those out, all right, on purpose. So if we go to static routes here, you should see I have two WAN connections here for two different ISPs. So, but what is interesting is I have it in, I need a little fanfare. Let's see here, high availability. So we actually have two FortiGates clustered together. And that's why in my little topology here, it kind of looks like a hot mess, right? So because the FortiGates have to connect to the same broadcast domains, also the heartbeat links, also over here, we're going to see that that doesn't matter. It just works. So let me try to bring that back. All right, so let's go ahead and start. So I'm going to first start with LA. Now remember, our goal here is to get full redundancy using IPsec. All right, so we're going to build the first tunnel from here to here, then here to here, and then we're going to build the other two from here to here, then here to here, and then we're going to go over to the New York side and do the opposite. So there should be a total of 4 on each side. So I'm going to head over to my VPN wizard. I'm going to go to my IPsec tunnels. All right, I'm going to hit create new, and luckily we're going from FortiGate to FortiGate. So I'm just going to say to NYC, right? Primary, okay? No NAT because we're going to public IP address to public IP address. And the gateway is going to be 10.200.3.1, which is the IP address of this remote FortiGate right here, okay? And then my super secret password that I'm not going to show anyone, I just showed everyone, right? All right, and now I'm going to pick my trust, automatically populates the local subnets, and then I'm going to get to the subnet that I'm trying to connect to locally, which is the 10.0.2. I hit create. Guys, that is it. Not only does it do the firewall policies for us and the inverse, it also does the routes for us. It's pretty amazing. So I'm going to go ahead and add another tunnel and do that all over again. But this time, I'm going to do a 2 NYC. Is that how I had it? 2 NYC primary. Oh, too many characters. I'll have to say prime 2. All right. And once again, I'm going to go to 10.200.4 this time, .1. So in other words, I am going to access the secondary ISP on this remote FortiGate here, okay? And then I hit next. Oh, my pre-share key. Don't tell anyone. Now, guys, honestly, I've seen so many times where my VPN tunnels failed when I first configured them. 9 out of 10 times, I fat-fingered the password because in real life, that'd be long and secure. All right. Here we go. WAN 10, oops, 10.0.2. Come on, Devin. 2.0/24. There we are. Hit create. Wonderful. So once again, the primary was going from WAN 1 to this WAN right here, and WAN 1 to the secondary WAN over here. Now I'm going to do it once again, all over again, but this time accessing it through the different ISP, this guy right here. So here we go. So I'm going to say to NYC backup. All right. Next. Then 10.200.3 2.1. Did I do that right? No, I did not. Sorry, guys. But now I'm going to use WAN 2 instead of WAN 1. See the difference there? Password, double check my password. Pretty amazing. Hit next. And once again, I'm going to pop it out. And for those that were in class, these are for the quick mode selectors it configures. All right, I'm going to go ahead and hit create. And then I'm going to add my last one, which will be my secondary backup. So 2N, come on, NYC back 2. Here we go. 10.200.4.1. All right, see how it wants to go out port 1. I'm going to go like, no, you know what? WAN 2 is going to be okay. And then I'm going to say password. Double check myself. There we go. All right. Then for my quick mode selectors. All right. Wonderful. So now we are done with the LA side. And as you can see, well, we have 4 tunnels. All right. If I go to my policy and objects, go to IP4 policies, you'll see it made all the policies too. Now, this is kind of a hot mess. I'm not going to lie. All right. In reality, if I was going to do this in a production network, I would probably take the time to create zones for these just so they weren't so congested. All right. So, but like I said, I was going to try to keep it simple with the wizard, just kind of as a proof of concept here. But then again, you know, we might be used to seeing a lot of interface pairs anyways. But there you go. It made it for us there. And also, which is really important, is the way that it knows to push it down the tunnel, and that is by the static routes. So the static routes, there we go. Boom, 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 boom. Doesn't get much easier than that, guys. So let's go ahead and fly to New York here. And now let's do the same on the New York side, but going the other direction. So isn't this cute? Starting with the newest version of 5.6, it goes, you know what, your password sucks. You should probably change that. So thanks, Fortinet. Now, if you're a network security admin and you don't change the default admin blink no password, I'm pretty sure you shouldn't need a little reminder popping you up. You probably should just go back being a sysadmin. Anyways, let's keep going forward here. So let's go ahead and do the same thing now. We're going to go to VPN Ipsec Tunnels, and I'm just going to do the wizard all over again, but this time in the opposite direction. So we'll do the first WAN connection first. So I'll say 2LA primary. All right, hit next. The public IP address of that connection. Okay, even found it for me. Thanks. Once again, guys, we're going right here. So we're going from, now remember, it's clustered, so you have to logically think of these as one. All right, in theory, I guess I could just have stacked them on top of each other, but that's no fun because can't see my cool load balancing going on there. But anyways, so we're going from here to here. So let me get that back. All right. The pre-share key should match. There we go. Now I'm going to hit next. My WAN interface. Look at that. Look at that. Man, you know, Fortinet surprises me. Every single version of the FortiOS that gets updated, they just put in like a little bit more details that just, I think, is pretty darn cool. So, let's see here. 24. Awesome. All right, there we go. So as you can see, we have our interfaces. Look at this is new. Look at that. It shows you all the different phases. Let's see here, local, remote. Look at that black hole route. What? We're gonna have to check that out later. I have no idea what that is off the top of my head. Let's go ahead and do another. And this time we're gonna do 2LA prime 2. All right, so this is now the WAN 1 going to the WAN 2 on the New York side. All right, and it has an IP address of 10.200.2.1, and we'll go ahead and use WAN 1. All right, pre-share key. Remember, double check yourself. There we go. We'll hit next. And we're doing port 6, and it's going to pop out at 10.0.1.0/24. We'll hit create. We'll add another tunnel. Now we're doing something different. Now we're doing our second WAN connection, or our secondary ISP, connecting here, and then we're going to do another tunnel going here. So let's go ahead and do that. All right, so we'll say 2 LA backup. Next. 10.200.1.1, but this time I'm going to force it to go out port 5. Remember, it's our secondary. So here we go, password. All right, good times, good times. There we go. Pop out port 6. All right, 10.0.1.0/24. Okay. Excellent. We have one more to go, so let's go ahead and add another, and this is going to be our WAN 2 to WAN 2. So, all right, here we go. 2 LA. Backup 2. No, is there enough characters there to actually say backup? Oh, there is. That's awesome. All right, here we go. I guess primary was just a little too long, but it's going to be 2.1. And once again, we don't want WAN 1, we want our WAN 2. All right. Pre-share key, password. Double check. All right, looks okay. Then for our quick mode selectors. I love that they put in the additional ones there. It's such a nice little touch. All right, here we go. Create. Wonderful. Perfect. So let's look at our tunnel list. All right, excellent. So as you can see, we have primary, prime 2, backup, backup 2. And then on this side, we have they're mirrored. So now I am not too sure what they meant by black hole. So let's go ahead and take a look at our policy and objects IP4. And we should see the matching pairs. Okay, so there they are. That's good. All right. Looks good. Like I said, I'd probably drop those in zones for simplicity and a production network, but not now. So let's go to network. Let's see if it made our static routes. Oh, interesting. So here we are, and it looks like in 5.6, it now automatically creates the black hole for you for a VPN tunnel. That is pretty cool. So we shouldn't need it here, at least I'm assuming. So let me back up a little bit. The black hole route is in case for some reason that VPN tunnel goes down. What will happen sometimes is that the traffic that was continuing out the tunnel does a route lookup because the routing table has changed when the VPN tunnel goes down, and it'll start pushing it out the default gateway, which is not the IPsec tunnel. So essentially, you get this I don't know how to describe it. Essentially, a route lookup error because the VPN tunnel is down. It will go ahead and stop pushing it through the VPN tunnel, so it starts using the default gateway, and essentially it looks at that private IP address that you're trying to go to and just drops it, and it breaks a lot of stuff until the sessions time out. So a way around that is to add a black hole route. So if the tunnel ever goes down, I'll actually click into one of these. All right. Instead of just not having a place for this destination, it'll actually route it to null, and that's what that black hole is, which means the bit bucket. So what's nice about this is you don't get that that weird push down the default gateway, because what happens is that the VPN tunnel will come back up, right? But the tunnel that erroneously is going out the default gateway will still continue to go out the default gateway. But here, because the administrative distance is so high, Remember, routing's like golf. Um, Essentially, this will disappear and replace it with the real VPN tunnel, and it'll start routing correctly once it comes back up. So I have had to personally use that when I was using monitoring software for my IPsec tunnels. I was doing pings down the tunnels, and even though my VPNs might flap once in a while, might go down and come right back up a few moments later, the ping traffic for my monitoring software would just start reporting it being down because it would start pushing it out the default gateway. So I found out about this black hole to find out that it will go ahead and reroute itself once the tunnel comes back up. That is so cool that it does it by default. Did not mean to go out on a tangent, but that is completely new in 5.6. I've never seen that before. So, but like I said, we have backups here, so shouldn't be a problem. But let's go ahead and do one more thing until we test it. Now, if you look at the guide, and there's two of them there in the comments field, or in the little, I don't know, I'm not a YouTuber, guys, sorry, the description in the video, it says to set the administrative distance differently according to their priority. So it took me a moment to think about this, but essentially, guys, if we have all of these together, made by default, all right, they have the same administration distance and the same priority, okay? Now, the FortiGate will normally participate in something called equal cost multipathing when it has the same distance and priority or the same distance and metric. Well, we don't want these things to pretty much bounce back and forth with each other. I mean, we could theoretically, but we just want one VPN tunnel, and then if one goes down, the second one will come back up. So I'm going to go ahead and set the administrative distance with the primary being 1, 2, 3, and 4, and then mirror it on the other side. That way, the tunnels will force to come back up and forced to be removed out of the routing table whenever there is a change. So if we did just priority, they'd all stay in the routing table. And essentially, not to get too much into it, but the session table would still be routing those routes that were in the active routing table if the priorities were different and the administrative distance was the same, and it wouldn't force those tunnels to do a re-lookup once the tunnel went down. So hope that made sense. If not, leave a comment, take my class, email me. I'll explain it a little better later. So, but this video is already getting a little too long. So here we go. So I set the primary to 2, the primary second, the primary to 1, the primary second to 2. And like I said, it was in the cookbook that it was showing us to do this, but not really explaining why it was important. And it's because of those lookups. So we want to keep the if I go down here to monitor and I go to my routing monitor, right? I want to keep only one VPN tunnel in there at a time. I do not want a bunch of them in there. All right. And as you can see, the 2 New York primary has the highest, well, the lowest administrative distance, which is the highest priority. So it's in the active routing table, blah, 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 blah. So there you guys go. Just as a comparison here, I haven't done anything with these guys yet. So if I go to monitor and I look at my routing table, or my routing monitor, we have 4 tunnels to pick from. So this FortiGate's going to go ping, 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 which is fine, right? If we kept them both up, but we want these things to fail over, right? Because maybe our primary WAN connections are nice, big, thick pipes, maybe some fiber connections, and then maybe our secondaries are just a little DSL cable modem backup, and we only want to use them when we need to. So let's go ahead and fix that. All right, so we're going to go back to our network, back to our static routes, and I'm just going to mirror those. So I'm going to say to LA primary, and I'm going to give it an administrative distance of 1. All right, primary second, administration distance of 2. Backup is 3. and then 4. Now, once again, the black holes would probably be necessary if we just had one VPN tunnel, but we have redundancies here. I'll leave them in there anyways. So, um, but they'd all have to go down before these bad boys would start showing up. So let's go back to monitor and routing monitor to take a look. And as you can see, we now just have a single tunnel. Now, if I go to IPsec monitor, nothing has happened yet. Why? Well, we haven't forced any traffic down the way. So let's go ahead and do that. So this computer here is in LA. So now we're testing it, right? So I'm going to do a ping loop. So I'll do ping, let's see, 10.0.2.10. I think that's the name of the PC over there. I might have to double check that. It should be this guy right here, but I can't remember off the top of my head. I better check that out, actually. Let's take a look. All right, so here we are in New York. Once again, I want to double check to see what my IP address is, because it might not be 10. All right. Yeah, it's probably not 10. All right, that would make sense. So let's figure out what that is. All right. Sorry about that. It is 101. Okay. Very cool. So let's go ahead and go back to LA now. It'd be nice if we had the right one. So let's do a 101 now. Oh, look at that. Beautiful, right? Beautiful. It's pushing down the tunnel. All is right with the world. I can come over here to my remote one, hit refresh. We have it up. Oh, that's so great. All right, now that's in New York. And then also on the local FortiGate, if I go to IPsec monitor, only one is up. Oh, that's just awesome. Okay, so now here's the thing. I'm going to go ahead and do a ping loop on the other side. So remember, this guy's in LA. Let me go ahead and grab New York again. All right. Now, the way that these things work is, and you witnessed this in class for those who took my class, it takes a moment, right, for the IPsec tunnel to actually recognize it being down before it will close the tunnel. And those are like the dead peer connectors and things like that. Now, if you're concerned about the amount of time that it takes for it to fail over, because we're watching it. And as we watch it, we're paying close attention to it. Now, in real life, though, we're usually not sitting here gawking at it, right? So we don't notice if it's going to be a few moments or not. But if you really want that top of the line latency, you can play around with the dead peer detectors. You just have to be careful because sometimes traffic will get dropped naturally, and you don't want it to be bringing down tunnels just because of a little congestion. Another suggestion that I still need to try out, but I just thought of off the top of my head, is to do like health link monitors through the VPN tunnels to maybe get a little bit more of control when it gets removed from the routing table. So maybe if I get some requests for that in class, I can maybe demo or try that out. So, but essentially what we got here, guys, is 2 pings going in both directions using WAN 1, WAN 1. So pretty neat. Well, zippity doo dah. The real trick here is going to be when something bad happens. So once again, here to here is where the connection is. So I'm going to right click this bad boy and I'm going to kill this switch, right? That switch is now dead. All right. And it is still pushing out. Okay. It works that well. Let's see here. Which one was it connected to then? To YC primary. Okay, that's different. I was expecting it to fail there. Let me do a reload here. To LA primary. All right. Oh, okay. To YC primary. Okay, that's different. I didn't think that would survive that switch being down, but it did. I'd actually have to do a lookup to see how that was working. Because I expected one of those to go down. Let's try something else here. Let's try to bring down, let's try to bring down our main primary one in LA. That's going to force some kind of, there we go. I was going to say that would have to force something to get brutal. There we are. See the timeouts happening now. I made it a little too resilient there for a moment. Anyway, so we just suffered a primary down, and we'll see if it comes back up. So now in class, it took us a good, what would you say, 10 pings for the dead peer connectors to really all come across and figure out that one was down or the other. Or maybe it just won't work. I'm just kidding. So, in fact, while it's actually doing its thing, let's go ahead and take a look of what's happening on the FortiGates instead of just staring at these ping loops. So, I'm going to go ahead and hit refresh. All right. So, 2 NYC primary is still considered up. All right. Nothing else is kicked in yet. Let's see what's happening at New York. Let's see if it figured that one out. All right. Well, I can still get there, so at least my WAN connection's still up. All right. Look at that. Oh, there it goes. Oh, I caught it. Did you see that? Did you see that? Oh, caught it in the act. There we go. 2 NYC backup has now come to life. Yeah, pretty cool, huh? 2 LA Prime 2. All right, not too bad. Not too bad at all. So, and that's a little weird still. I'm still trying to figure out how that all works because technically speaking, this network right here is that guy, and I'm not too sure how that's going to work. See how it's still timing out? Let's load this guy back up. Because I actually have pretty good faith that everything would start kicking up eventually. See, exactly. Just had to wait a little bit. All right. Do a little refresher. All right. C2 LA Prime 2. All right, so it's now going to that secondary. It took it a moment on the New York side to realize that the primary was actually down, right? For it to go to the secondary one. So we're actually going from the second WAN there and also from the second WAN there. So it just took a moment for it to kick in. So I didn't even need to turn on this switch here, but I'll turn everything back on. Actually, you know what? Let's just keep rolling with this. I'm going to kill the secondary here and the primary here and see if it can't converge itself. And once again, I know for a fact that we can get more intelligent. Let's see here. Oh, that's not what I was doing. I lost it. We can get more intelligent VPN tunnels converging. We would just simply need to do health monitors to do so, and that's an idea. See how we now have 2 NYC primary back up, right? Is it still pinging? Yeah, it's still pinging, even though I've killed, let's see here, killed the secondary, killed the primary. So not too bad there. And yeah, it's still going on the New York side. So not too bad, right? I know I was kind of doing a sloppy job flopping through that. Here we are. And eventually that will time out and die. So, or maybe it won't because we're going to New York backup. I got to think of the directions here. All right. So, bottom line though, it stayed up. It stayed going. Let's just keep rolling with this. And I'm actually going to flip-flop these. So we now have the secondary alive over here, the secondary alive over here, okay? And then these two guys right here have now been powered off. Now, another thing I should note that's also affecting this is you guys got to also realize is that these things are actual switches that are booting up. So that takes a little bit for it to get up and running too. So, but you see how we have that down. And it's like watching paint dry. But it should work. So once again, just as a review, what we did here was create 4 tunnels on each side. So primary to primary, primary to secondary, then secondary to primary, primary to secondary, then flipped it going the opposite direction. So once those switches power back up, right? And I'm wondering if I wasn't actually using switches, maybe just putting down a down interface, this would happen a lot quicker, but I wanted to create something a little bit more realistic in doing the demo, because that's the problem with lab environments, right? When we suffer an outage, it isn't just, you know, us on purpose putting down an interface or closing an interface. So let's see here. Let's go ahead and see what's going on. Maybe we can catch it again in the act, right? So here we go. So to NYC backup. So that is back up, that is back down. And then over on the New York side, I was expecting it to kick me out. Okay. You can do it, buddy. Which is funny, because I could just, come on. You can do it. Because I could actually just access it from this side. Oh, look at that. That's taking a little bit longer than I thought it would. And that's me accessing my remote FortiGate publicly, which we never have in real life. So let me just try to go on the New York side and see what's going on here. There we go. All right. Ah, it's still down. Let's take a look, huh? So here we go. Let's go to our VPN tunnels. So yeah, we have a 2 LA backup too. So we do have a tunnel that is up. All right. Now, I also don't know if it's just a matter of these guys right here needing to time out. Let me try that. Maybe. Huh? I don't know. Let's see what's happening on this side. No, I'm still timing out over here too. Maybe I have to perfect this a little bit more. Oh, see, just got to be a little more patient. So, like I said, guys, that's the only problem that I've really seen with this, is that it's not like a quick, hey, I'm down. So, and it shouldn't be. Now, that many packet losses, maybe that would be extreme. I mean, that was a good 5 minutes or something staring here, waiting for it to converge. But out in the real world, I'm not too sure if that would be the case, because I'm powering down switches and everything else. Why do VPN connections go down to begin with? You know, there's many different variables there, from losing an actual WAN interface to maybe traffic just getting so congested that it's getting dropped and the dead peer connectors keep on kicking on. But that should be enough to prove the proof of concept. So once again, by doing the wizard, right, 4 times on each side, and then changing the priorities by changing the administrative distance based on how I wanted them to conversion order, we can get redundant connections here. So if any of my students do watch this and they've had their own personal experience with it working or not working, feel free to email me and let me know. Or if there's something else you want me to lab up and try, let me know. Um, because, in the real world, things can act a little bit differently. So, but that should still be a proof of concept there. So, um, and then I don't know if anyone's ever going to find these things out on the internet and actually watch them on YouTube, but of course you can comment. And I'm not going to lie, I'm not going to watch them or look for comments. I might stumble across them once in a good while, but anyways, I will go ahead and end it there. I hope you guys enjoyed this and it was helpful. If it wasn't or a hot mess, just let me know. I can always re-record them. So, well, thank you very much, and I will see you guys next time.